Good evening. My name here is Philip Goble. Doing a short presentation for one of the classes that I'm taking at Mary State, and I will try to turn these around to where you can see what I'm doing here. I'm going to do a short presentation on Wireshark. And let's open Wireshark, and I'm going to open an internet browser as well to start a little traffic over the actual network. So if we go to Capture and choose the interface that we want, which I'm using a Dell, has Intel Pro. I'm going to start the capture. And in a few minutes you'll see it start to work and start to capture data. This is what's being sent over the network. If I click on Mozilla and generate a little traffic, for instance, and then go back to Wireshark, then I go to capture and go to stop. Now I'm going to stop the present capture that I have. So let's look at what we captured. First, there's an ARP request here. Want to know who has 192.168.1.105. And then there's a tail out here. It's 192.168.1.104. And that's just another computer system on this particular network. As you see, this 192.168.1.1, this is my default gateway. And it shows the SSDP here. And if you get to looking for information or data, there's just an ARP request that was being caught here. And then you have an MBNS as far as it's storing an actual lookup. And let's see what we can get from here. Interface, let's start a new capture, and let's actually continue without saving for this particular capture, and let's create a little bit of traffic. I've done a search for eham.net. This is the website that I want to look at. As you can see, Wireshark is working. And we go to capture and we stop the interface for the capture. And if I go to look at what's being caught, or what's being actually captured here, here's my IP address, which is 192.168.1.102. Excuse me, I've had a bit of cold. And if you go to the subheadings down below, then we get an idea of the frame size. Here is the frame number, which is 395. 54 bytes of data were on the wire, 55 bytes were captured. The arrival time, of course, was October 26th, which is today. And as you can see, it starts at 18.0229. And then we go on down and we search the frame length again. This also gives us the frame length in bytes. That was the actual size, and then the capture length. If you go down and look at the destination and the source, you see the internet protocol here that we're using. The source is 192.168.1.102, which is me. The destination, if you'll notice, is 69.36.242.134. And this is the actual website that I was looking at. And I'll show you just in a minute whenever I do a DNS search. Of course, the version we're using is 4. The head length is 20. And the total time to life on this particular packet is 128. These are just a few things that I'm highlighting in the software that you can actually do with Wireshark. Again, here is the source, here is the destination, and this is a checksum for the header. This is what TCP/ID it checks for packets that are being sent, good or bad. And then you have a window size, and then down here you have a sequence and an acknowledgement, and it checks for duplicates as well. So if I go up here and the filter and select the filter and type in DNS and do a search for the DNS, as you see, I get a standard query for the DNS that I was looking for. Now let's see if we can go find the address that we were on. Let's see what this one shows. Excuse me again. And we have queries here, and let's come up with a self-safe browser client, which was from Google. That's not the one we're looking for. Basically what DNS does is it takes an IP address and gives it a valid name that we can remember. it's easier for us to remember something like www.google.com versus the actual IP address 6676.227 for the O. So let's see if I gave it long enough time to be able to capture anything from EM. Yeah, here we go. And here's the DNS. And as you can see here, listed is right underneath the very next to the very bottom in this window. It shows www.eham.net. Type A class IN. So that gives you an idea of what you can do as far as searching for DNS. If I want to go back and look at the actual TCP IP data, then I would simply type that in on the filter, all in lowercase, of course, and then simply hit apply. And this takes us back to the original screen that we were at. You can do a capture on many different interfaces. You can analyze and select many different types of filters. You can also actually look for actual port numbers. If you see, we know that HTTP uses a port of 80. So if you do a search and look down through the data that you've captured, you will run across the particular port that you are using. And the process, here it is, destination port HTTP, which is 80. That is the standard internet port for most proxies or anything that deals with the internet. So just a short, brief discussion about Wireshark. It is the same as Ethereal. It is free and open source. So give it a try. You can see what kind of information that your network is producing.